alkynes? Alkynes are hydrocarbons in which there's a triple bond between carbon and a carbon. And this triple bond can happen in the sense that it can be on the first carbon, and that one we call terminal alkyne, or it can be in between other carbons, and that one we call internal. That's what we call internal alkyne. Now, alkyne have the general formula of CnH2n-2. So this N gives us the number of carbons, and H2n-2 gives us the number of hydrogen atoms in that functional group. For example, if we have pentane, if N is equal to 5, so meaning we have 5 carbons. So let's look at the number of hydrogen atoms. So hydrogen is going to be 2 times 5 minus 2, and that's going to give us 10 minus 2, and that's going to give us 8. So we can say C5H8, and we can draw that. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So let's say here we have our triple bond. So this is going to be our H. So we have our H, and here we have our H, and H. So how many protons are here? 1, 2, 3, 4, 5, 6, 7, 8. So this is what we call pentane. Okay, so that is how alkynes looks like. So let's look at naming of alkynes. In nomenclature of alkynes, the first thing that we need to do is to identify the longest chain, and the longest chain should form part of the triple bond. So for example, if we have something like this, okay, let's just give it, okay, so let's say we have our triple bond there. So let's identify the longest chain. So in this case we have internal alkyne. So if we say 1, 2, 3, 4, 5, 6, so we have a substituent there. Or if we say 1, 2, 3, 4, 5, 6, so you find that when we use 2, if we go towards the left hand side, it's going to give us on carbon number 2, and if you go towards the right hand side, it is going to be on carbon number 4. So this one we are not using. We are using this one because the triple bond should give us the least or the lowest number. So now we can name this. How many carbons? 1, 2, 3, 4, 5, 6. So it's 6, so it's going to give us, okay, hexane. But now look, our triple bond is on carbon number 2, so it's going to give us X2-ine. But on carbon number 5 we have a substituent, and this substituent is a methyl group. So we're going to say 5-methyl X2-ine. Fair. So that's how we can name this one. So in case whereby in some scenarios it can happen that now we have, let's say, we can have a group like this. Let's say here we go. Let's say yes, a methyl group, and here is OH or alcohol, and in this one we have ethyl, and we have methyl. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So let's say 8, and in this one we have a triple bond. So now if it happens that this is what we have, our structure looks like this, and we have seen it is having 8 carbons, and therefore we can name according to what we know. We can name going to the left hand side by saying 1, 2, 3, 4, 5, 6, 7, 8, or we can name going to the right hand side by saying 1, 2, 3, 4, 5, 6, 7, 8. So now we have a triple bond on carbon number 1, but we also have alcohol present in this chain. When alcohol and triple bond are present together, the alcohol group is going to be given the first priority in naming over a triple bond, and therefore in this case then, numbering going to the left, we are going to say no, but when we move towards the right hand side, then moving towards the right hand side, then you are going to tick it. So now, meaning that we are going to name our structure going to the right hand side, giving alcohol the first priority, and this is going to look like this. So now it has 8, and that's going to give us let's say octane. Let's leave it from there first. And now if you look on this structure, we have 2 types of substituents. We have 2 ethyl groups and 2 methyl groups. So E comes before M, and then ethyl is going to come first. So we have ethyl on carbon 1, 2, 3, 4. So we have ethyl in carbon number 4 and carbon number 5. So we're going to say 4, 5 diethyl. On carbon number 2 and carbon number 3, we have our methyl group. So we're going to say 2, 6 dimethyl, and then our triple bond is on carbon number 7. So I'll put here 7. Then you bring this octane, 7 octane, then alcohol will follow because alcohol is on carbon number 1, 2, 3. It is on carbon number 3, and we're going to say octane 3 all. So this is the entire name of what we have. So let's now look one by one. It tells us that this 4, 5 diethyl. So it means that there's ethyl groups on carbon number 4 here and carbon number 5, and 2, 6 dimethyl. So we have 2 and 6, and then 7 octane. We have triple bond on carbon number 7, and 3 all, meaning that the alcohol is in carbon number 3. So that's how we can name this structure. In certain cases, you can have a triple bond present, 2 of them. So for example, we can have a triple bond like this present. Okay, so if it happens like this, you can see, and if we name going to the right hand side, so we're gonna have 1, 2, 3, 4, 5. So the name is pentane, right? But because there is 2 triple bonds, then whenever there are 2 triple bonds or double triple bonds, the name will end in diene. This di tells us that there are 2 triple bonds, and this ine tells us that it's a triple bond. So let's look. We have 1, 2, 3, 4, 5. So our first one is on carbon number 1, and the second one is on carbon number 3. So we can say 1, 3 pent diene. 1, 3 pent diene. So it tells us that I have two triple bonds, and they're in carbon number 1 and carbon number 3. Let's look at also sometimes we can have a complex structure whereby we have, let's look an example, we have a triple bond and a double bond, and we can go ahead and let's say we have ethyl and then we have methyl here. So let's say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the longest chain is 8, and when the longest chain is 8, look at it. We have a double bond between carbon number 4 and carbon number 5, and we have a triple bond on carbon number 1 and a carbon number 2. So now if you look at carbon number 2, you can see that this hydrogen, if I was to put this here and say this is hydrogen on this side and this is hydrogen on this side, and this first priority on this is second priority, and on this carbon this is second priority and this first priority. So these are things which are opposite each other. The high priorities are opposite each other, and this one is going to give us what is called E. Okay, so we're going to have our E because of this double bond. So from here we can then start to name our structure. So we have E, and then in carbon number 6 we have ethyl. So we're going to say 6 ethyl. Okay, and in carbon number 3 we have methyl. So we're going to say 3 methyl. Now let's look on carbon number 1 and carbon number 2. We have a triple bond, and carbon number 2 and carbon number 4 and carbon number 5 we have a double bond, and our structure is 8, which is going to be oct. Okay, so let's say 3 methyl, then we're gonna put here, let me grab it. So we're gonna put here to have oct. Our double bond is on carbon number 4, oct 4 N to means alkene N. Then our triple bond is on carbon number 1, and we're going to say 1 ine. So this is the name of our structures: E, 6 ethyl, 3 methyl, oct 4 and 1 ine. It sounds nice, right? So that is how we can give our structure, or our structure, a name. You can have a triple bond and a double bond on outside or in the terminal carbons. For example, now you have a double bond here, you have a triple bond here, and you ask yourself, what should you do? In that scenario, you have to give a double bond first priority over a triple bond, and by that we are going to name from left to right. So this is 1, 2, 3, 4, 5, 6. So that is hex, right? So now we can go ahead and name it hex, eggs, and then our carbon double bond is on carbon number 1. So we're going to say X, 1, N. Then our triple bond is on carbon number 5. So we are going to say 5 ine. Okay, so this En, 1 ine, tell us that our double bond is on carbon number 1, and 5 ine tell us that our triple bond is on carbon number 6. So this is how we can name alkynes. You just need to identify the longest chain, and also you need to be very careful, especially if you have other substituents, and also if you have two different functional groups like double bond and triple bond, where they are,